Friends, today we are going over adding and subtracting rational expressions. That should be super fun. We're going to start off with a little warm-up. You should pause the video and try the warm-up yourself, and then you can jump in with me, or you could just hang out with me while we do it. So the key when we're adding fractions is we need the same bottom, which means that we need a common denominator, and our goal is always to find the least common denominator, or the LCD. So in these first two, they already have a common denominator, and when that happens, we just add the tops, right? So I'm going to have 3 over 5. Subtraction, you subtract the top, so I'm going to get 2/7. For this one, 1/3 plus 1/6, they don't have the same denominator, so I'm going to look for a common denominator between 3 and 6, and what that's going to be is 6. So the way I'm going to achieve this is technically I'm multiplying 2 over 2 times this first one, which will give me 2 over 6 plus 1/6. And now that I have a common denominator, I can add the tops. So I'll get 3/6, which I can reduce to 1/2. Same exact idea over here. I have 3/4 minus 1/2, so I need to rewrite this as something with the same denominator. So officially what I'm doing is multiplying the second fraction only by 2 over 2, and then I can just subtract. So adding and subtracting rational expressions works the same exact way. What we need to do is just ensure that they have the same denominator, and if they have the same denominator, then we just add or subtract the numerators, and then we just write out the result basically. So if I'm looking at this, it says first state the domain restriction, so I'm going to look at my denominators and say, okay, the domain is going to be that x cannot equal 3. That would make the bottom equal 0. And then when I look at this, their bottoms are the same, so I can just add the top. So I'm going to do x minus, here's where it's a little tricky, we have to pay attention that we're subtracting all of that, and then I just do over x minus 3. So that's going to distribute out, and I'm going to end up getting, right, so negative 2x minus 2 over x minus 3. If we want to be super technical, we should factor out the negative 2 just so that it's really obvious that nothing can be reduced. But if you left your answer like this, that would be fine as well. All right, it's your turn, so you should pause the video and you should try it yourself. And then unpause when you're ready for me. You ready for me? Okay, cool. Domain, bottom can't equal 0, so I'm going to get x cannot equal negative 5/2. It looks like I already have the same bottom on both, so I'm just going to add the top. So 2x squared minus 4 plus x plus 3 all over 2x plus 5. And then we just combine any sort of like terms here. So I'm going to have 2x squared plus x and then minus 1 all over 2x plus 5. Again, we could try to factor the top, but I know that nothing is going to cancel with a 2x plus 5 because there's no way I'm getting a 5 in either set of parentheses when I go to factor this. At best, I could get a 2x and an x, and then I'm going to have a 1 and a 1. So I'm never going to get a 5, so I don't really need to do this. Now, if you can factor really fast, like I just did, well, then maybe you go for it and you get that this is what it factors to. And then you can see for a fact that it does not cancel. But you know, we try to be a little bit fast here and use some of our logical brains here and say that there's no way I'm getting a 5 there, so it's going to be simplified already. So, least common denominators. This is the part that most people find to be challenging at first until you get the hang of it. It works the same way with numbers. It's just like a little harder to maybe see that that's what's happening. So let's say that I had two different numbers here. And I'm trying to think of some on the spot because it would have been smart for me to have them ready for you, but I did not. So let's do something like 30 and 18. Okay, so let's say these are my denominators. What I want to look for is the least common denominator. So technically I could just multiply the first one by 18 over 18 and the second one by 30 over 30, and that's going to give me a common denominator, but it's certainly not going to be the least one. So what we're officially doing is we would take something like 30 and we would break it down into its smallest pieces. So that would be like 2 and 15, and then like 3 and 5. So we would be able to say that the factors that represent 30 are 2 times 3 times 5. If I do the same exact thing with 18, I would get 2, 3, and 3, basically. So 2 times 9. So I would get 2 times 3 squared, officially speaking here. Let me erase my little scratch work over here. So what the LCD would be for this is I basically would factor everything, so that's what I just did, and then it says express repeated factors as power, so I did that with the 3 squared. then list all the different factors of the denominator. So I'm going to start with the first one. I'm going to say, hey, I'm going to start by listing off 2. So I'm going to say, there's 2. Then I'm going to do the next one, 3. Okay, cool, 3. What I want to do is just include just a single one for now. And then I'll say, hey, there's a 5. And I jump over here and I say, here's 5. And now I'm going to jump to the next one. I'm going to say, hey, 2, is that already on my list? Yes, it's already on my list. Great. All right, when I get to 3 squared, I only have 1 3 on my list. So what I need to do is bump that up to have the highest power. So that's what this says. Only list the factor with the highest power that it appears. So between 30 and 18, the least common denominator would be whatever 2 times 3 squared times 5 would be. So I don't know, I can't do that math in my head, but that would be what the least common denominator would be. So let us do that with some algebra now. So first thing, they want us to state domain restrictions and find the LCD. Step 1 in all of these things is always going to be to factor everything. So I'm going to factor this, x minus 4, x plus 3. And factor this guy over here, I'm going to get x minus 4 squared because it is a perfect square trinomial. So domain, pretty straightforward. X cannot equal 4 or negative 3. All right. And then my LCD, I'm going to start with the first one. So I'm going to include the x minus 4 right there. So x minus 4. Then the second one, x plus 3. So I'm just kind of moving in order from left to right. And then when I get over here, I go, oh, wait, this one has a squared. So let me go back over here and add that as a squared. So the least common denominator would be x minus 4 squared times x plus 3. This one over here is already factored for us, so it's going to be a little bit easier for us to figure this out. So my domain, let's do that first so I don't forget. 0 from that guy right there, 1 from the next one, and negative 1. So I'm just going to write that as plus or minus 1. And the 4 doesn't do anything, and then I already have these other guys. So that's actually everything. I'm just going to clean that up because it looks messy. All right, so now let's do LCD. So I'm going to start with just going in order. So x is not on my list yet, so I'm going to put an x there. Next thing I'll do is going to be the x minus 1 squared. So I'm going to include all of that, x minus 1 squared. Next, I'll do an x plus 1. That doesn't look like it's on my list yet, so I'm going to do x plus 1. Now I'm going to jump to the other fraction and keep going with it. So I have 4. That's not on my list anywhere, so I'm going to throw a 4. We typically write the numbers in front. That's why I did it that way. Next one would be an x minus 1, and I already have that here. Even though it's 2, that's okay. It's allowed to be bigger, just can't be smaller. And then I have an x plus 1, 3, and I don't have a 3 there, so I need to bump this guy up to make it a 3. And that will be my LCD. All right, so 4x, x minus 1 squared, x plus 1 to the third. So I need to pull all the factors, right? So that's what I'm doing, list all the factors, and then I'm going to include the highest power of it. And I'm not going to like repeat it. So I'm not doing x plus 1 and an x plus 1 to the third. I'm just picking the x plus 1 to the third, the thing with the highest power. All right, you should pause the video and you should try this one yourself. So find the domain and the LCD. And then I'll be here ready and waiting to go over it with you. Okay, factor everything. X minus 2, x plus 2, and then this guy's going to be x minus 2, x plus 1. So our domain is going to be that x cannot equal plus or minus 2 and cannot equal negative 1. And my LCD is going to be, let's see, x plus 2, x minus 1, and then x plus 1. All right, so I'm basically including that. This guy's already on the list, so I'm not including it again. And then that one. Over here, nice and already factored for us. So I'm going to have the domain is x cannot equal 0 from the x squared right there. And then I'm going to have a plus or minus 2. And that looks like everything. All right, LCD. I'm going to have a 3x squared. That's going to take care of the 3, the x squared, and the x right there. Then I'm going to have an x plus 2 squared. That's going to take care of this x plus 2 and this x plus 2 squared. And last, I will have an x minus 2 to the fourth. That's going to take care of the x minus 2 to the fourth and that x minus 2. All right, so I just look at the factors, pull the one with the highest exponent. So now we get to the adding and subtracting. So what we're basically doing is the same thing like I did way in the warm-up when I was multiplying top and bottom by 2. We're just going to choose now to multiply top and bottom by a polynomial, a factor, x plus 1 over x plus 1, something like that. So Let us try to do this. I'm going to start off with our first step, which is to factor everything always. So I'm going to have x plus 2 and x plus 1. And then this is going to be x plus 1 and x minus 1. I'm going to state my domain so I don't forget. So it's going to be x cannot equal negative 2 or plus or minus 1. So that's my domain. And then my LCD is going to be x plus 2, x plus 1, and an x minus 1. Right? So just those three. And what I want to do now is I want to focus on kind of what's missing in each of the individual fractions. So the first fraction is x over an x plus 2, x plus 1. So the thing that it's missing from the LCD is an x minus 1. So I'm going to do top and bottom x minus 1 for that one. For the next fraction, I have 2x minus 3. I'm going to put it in parentheses because I know I'm missing stuff. I'm going to have to multiply, so I don't want to lose track of that. And what it's missing from the common denominator is the x plus 2. All right, so I have to do top and bottom x plus 2. So now that I've done this, I'm going to distribute on the tops. And since I have the same bottom now, right, the denominator is the same for both of them. Even though it's written in a different order, I still have an x plus 2, an x plus 1, and an x minus 1. I can combine these as one fraction now. So I'm going to distribute up here. That's going to give me x squared minus x. I'm going to FOIL this guy over here, so 2x squared. I'm going to get 4x minus 3x, so that's going to give me just plus x and then minus 6. And the whole thing is over x plus 2, x plus 1, and x minus 1. Now, key thing here that people tend to do that trips them up is that they try to FOIL the bottom out. We don't need to. The bottom can stay factored always, right? Once we factor something on the bottom, it stays factored. We want to simplify the top so that we can see whether or not it would be able to cancel with other things later. For example, this one, we end up with 3x squared. The x's cancel, minus 6 all over. The x plus 2, x plus 1, and x minus 1. And technically speaking, I can factor the top a little bit more. It would factor to a 3 over x squared minus 2. And I know that that's not going to cancel with anything. So honestly, I could leave my answer as the 3x squared minus 6, or I could write it as 3 and then x squared minus 2. Both would be correct here. I would accept both, okay? So either one. So again, what we did is we found the LCD, we focused on what was missing from each of the two fractions, and then we multiplied in order to introduce it, write it as one fraction, simplify the top, and see if anything else happens. All right, so here is your turn. You should give it a go and see how that works out for you. All right, you should have tried it yourself. It looks like our bottoms are already factored. That's really nice for us. Our LCD is going to be x plus 4 and x minus 2. And my domain is going to be that x cannot equal negative 4 or 2. All right, it looks like the first fraction is missing a x minus 2. So I'm going to do x minus 2 on top and bottom, so x minus 2. And the second fraction, it looks like it is missing the x plus 4, right? So I'm going to have x minus 2, and then I'll do x plus 4, x plus 4. All right, now we just got to simplify, right? So I'm going to have x squared minus 5x plus 6 plus x squared plus 4x all over my x plus 4, x plus x minus 2. Remember, we don't ever FOIL the bottom. We just leave it alone. And then I'm just going to simplify. So up top, it looks like I have a 2x squared, a minus x, and a plus 6. All over x plus 4, x minus 2. We should see whether or not this can simplify. So I think if we try to factor this guy, we're going to get 2x and what? I'm trying to do math in my head while talking. It's kind of tricky. I think if we did 2x times 2, negative 2, and then, oh, but it's positive 6. All right, so I don't think this is factorable. If that had been negative 6, then we would have been able to do like plus 3, and this would have worked, but I don't think that's factorable with a positive 6 there. So then this is our answer, right? But notice how I'm always checking to see whether I can reduce, because we always want to simplify our rational expressions as much as possible. All right. So subtraction's the same exact idea. We're just going to factor everything and see what happens. So I'm going to get x plus 1. Here I'm going to get x plus 1 squared. So my LCD is going to be x plus 1 squared. My domain is going to be that x cannot equal 0 or -1. And let's see, what this first fraction is missing is another x plus 1, because it only has one of them. And what the second fraction is missing is an x. Okay, so I'm going to do x times x plus 4. So I'm basically focusing on what each one is missing in order to get what it needs. So this one was missing an x plus 1, and this one was missing an x in order to get it to have it. So that's why I have an x plus 1 right here and an x right here. And then I'm just going to write it all over that LCD, so x plus 1 squared. Wow, that got really messy when I tried to make it like green and red. Oof. All right, that says x plus 1, I swear. We're going to FOIL, so we get 3x plus 3. I'm going to distribute the negative x there, so I'm going to get minus x squared minus 4x. It's all over that x plus 1 squared. And then I just rewrite things. So negative x squared minus x plus 3 all over x, and then x plus 1 squared. Again, we should just double check that something doesn't simplify further, but I don't think there's any way to multiply to 3 and get a -1 there, even if we factored out that negative sign. All right, your turn. So try it with this one, see if you can figure things out, and I will be here ready and waiting for you when you're done. Do you actually pause the video? You probably don't. It's okay. It's just good practice, you know? Ooh, I'm writing the domain instead of this. Oof. All right, my LCD is going to be x and then x plus 2, x minus 2. My domain is going to be that x cannot equal 0 or plus or minus 2. The first fraction, it's missing the x, and the second fraction is missing the x plus 2 and the x minus 2. All right, so I'm going to go to add these guys in here. So first one is missing an extra x, so I'm going to do x times x squared. That's going to give me x to the third, and here it's missing both the x plus 2, x minus 2, so I'm going to have minus x plus 2, x minus 2, and then it's all over my LCD x plus 2, x minus 2. And then we just got to simplify the top here a little bit. So I'm going to have x to the third minus an x squared plus 4 after we do all that simplification. And then we have x plus 2, x minus 2. I don't think this simplifies to anything. Factoring x to the third minus x squared plus 4 doesn't sound like it would be fun. So there you go. All right, so that's adding and subtracting with rational expressions. So you have some homework here. There's two ways of doing these ones. You can find the LCD first and then try to combine them, or you could try to simplify them first, which I think is easier. So see if you can cancel anything top and bottom. You can't for this one as I'm moving my mouse over it, but you can definitely for this one. There's things that we can cancel out vertically. Remember that you can't cancel sideways across a addition or subtraction sign, only through multiplication. And then you just have some practice here with some that get a little crazy, but nothing too terrible, I think. And then, as always, you have a bunch of optional extra practice in case you'd like to do a little bit more. And yeah, don't forget to like and subscribe, and I hope you enjoyed the video. Catch you later. Bye.